Hi, how are you? Today we are going to discuss another important topic, that is what is what are the properties of arithmetic progression. In the previous video we already discussed what is meant by arithmetic progression and what is meant by arithmetic mean and how to find the sum to n terms. In this video, it is very important to know what are the properties of an arithmetic progression. Shall we go to the topic? This is the property number 1. Property number 1 says that if A1, A2, A3 and so on are in AP, shortly I am writing it as AP instead of writing full form of arithmetic progression. If you take any arithmetic progression, say this is with common difference D, then if you add or subtract any constant from all the terms, then that will also be form an arithmetic progression with the same common difference. See, for example, I am taking, in this example, I will take an AP starting with 8. So 8, 12, 16, 20 and so on. This is in AP since the common difference is T2 minus T1 is 12 minus 8 is 4, 16 minus 12 is 4, 20 minus 16 is also 4. Therefore, is an AP. Is an AP. Now, as per the property number 1, as I said, if you subtract or add any constant from all these numbers, then the result will also form an AP. For example, I am subtracting minus, that means 2. So 8 minus 2 is 6. 12 minus 2 is 10. 16 minus 2 is 14. 20 minus 2 is 18. Will also be an AP. Check it whether it is an AP or not. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is also 4. That means common difference is becoming same. In a similar manner, if you add any constant to all the terms of an AP, then the result will also form an AP. Check that also. Say I am adding 2 plus 2 for all these terms. 8 plus 2 is 10. 12 plus 2 is 14. Again 16 plus 2 is 18. 20 plus 2 is 22 and so on. If you observe, 14 minus 10, T2 minus T1. You know the common difference can be calculated by using T2 minus T1 or T3 minus T2, whatever it may be. 14 minus 10 is 4. 18 minus 14 is also 4. 22 minus 18 is also 4. So, these two are having the same common difference as the original arithmetic progression is having. In this case, CD common difference is 4. So, in these two cases also, which are formed after adding or subtracting the common constant term, will also be 4. So, this property says that if any numbers are in AP with the common difference D, then if you add or subtract any constant, then the result will also form an AP with the common difference D, which is same of the original arithmetic progression. Now we will go to the second property. Property number 2 says that if you take any arithmetic progression, let it be A1, A2, A3 and so on, AN, is in AP with common difference D. Then if you multiply each term of the AP or if you divide each term of the AP, the result will also form an arithmetic progression with common differences K into D. Whatever the constant you are using to multiply each term or whatever the constant you are using to divide each term of the AP, then these are the common differences of the newly formed arithmetic progressions. A1, A2, A3 and so on is an AP. They have given that. You have to verify after multiplying all the terms with a constant k and dividing all the terms with a constant k are also in AP with the common differences, but common differences will change here. Why? Because you are multiplying each term with k, means you have to multiply or divide the common difference also with that k. We will take an example. See, if you take the example of 4, 6, 8, 10 and so on, which is an AP, arithmetic progression. Now term 1, term 2, term 3, term 4. Common difference D is equals to T2 minus T1. 6 minus 4, that is equals to 2. Now I am going to multiply each term with a constant, let it be 3. Okay. K is equals to 3. Then 4 into 3 is 12. Okay. 6 into 3 is 18. 8 3 is 24. 10 3 is 30 and so on. If you verify the common difference, 18 minus 12 is 6. 24 minus 18 is also 6. 30 minus 24 is also 6. Means it is also an AP with the common difference 6. That means K into D, where D is the common difference of the original arithmetic progression, and you know that is 6 minus 4 is 2. Therefore, if you multiply K with 2, that is equals to 6. Similarly, if you divide all the terms of an arithmetic progression with a constant term, then the result will also form an AP. I am verifying by taking. See, I have taken already an AP. I am dividing all the terms. Let the constant be 2 in this case. I am taking for example. Therefore, 4 by 2. 4 by 2 is 2. Okay. 6 by 2 is 3. 8 by 2 is 4. 10 by 2 is 5. And so on. Which is an AP. Why? Because if you verify the common difference, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. Common difference is same if you subtract the consecutive terms. Then will also form an AP, and the common difference is D by K. D by K. Here D is the common difference of the original arithmetic progression, and you know that is 2. 2 by 2, which is equals to 1. So this is very important property. Students doesn't know whether you will get an AP if you multiply all the terms of an AP with a constant term. Now property number 3. Into property number 3 and 4, these are very important. First I will explain this one, then I will come back to this one. What this property says is that if A1, A2 and so on AN and B1, B2 and so on BN, I am taking two arithmetic progressions whose terms are A1, A2 and so on AN, B1, B2 and so on BN. But their common differences are also different. The first common difference is D1 and the second common difference is D2. Then I am adding or subtracting the corresponding terms of two APs. See, the corresponding term of A1 is B1. Rather, if you are adding or subtracting all the terms, then the result will also form an AP with the common difference D1 plus or minus D2. Means if we are adding the corresponding terms, we have to add the common difference also to get the common difference of the result. See, for example, if I take 1, 2, 4, 6 and so on. Okay, I am taking another one, 3, 5, 7 and so on. These are two APs, and you know that the common difference of these D1 is 2. I am letting, and this common difference D2 is equals also 2. What I am doing is on addition of these corresponding terms or on subtraction also you will get an AP. We will verify it. If you add 2 plus 3, the result is 5. 4 plus 5, 9. Okay. 6 plus 7, 13 and so on. This is an AP. How you are getting the new AP? See, verify it. 9 minus 5 is 4. 13 minus 9 is also 4, which is an AP. If you want to find the common difference of this AP, it is enough to add the common differences of these two APs, since we are adding the corresponding terms. See, what is that? 2 plus 2, D1 plus D2 is equals to 4. You are getting the same. Similarly, on subtraction of the corresponding terms, you will get an AP with a common difference D1 minus D2 or D2 minus D1. That depends on your subtraction. Okay, I am subtracting second AP from the first AP. 3 minus 2 is 1. Okay, 5 minus 4 is 1. Okay, 7 minus 6 is 1, and so on. See, this is also an AP, but with the common difference 0. That is called a constant arithmetic progression, since there is no progression, there is no progress in the terms. If you see, this is an AP, and if you want to obtain the common difference of the result D2 minus D1, 2 minus 2 is 0. That is a constant arithmetic progression. Coming to property number 3. This is very important, my dear students. Keep focus on it. I am taking two different arithmetic progressions whose terms are let A1, A2 and so on, A1, AN, B1, B2 and so on, BN. Now I am going to multiply or divide the corresponding terms of two APs. Then keep in our mind the results will not be in AP. An addition or subtraction, they will be in AP. But if you multiply or divide the corresponding terms of two APs, we will not get an AP. You may verify that. So what I am doing is, I have taken two arithmetic progressions with two different common differences. I multiplied the corresponding terms A1 B1, A2 B2 and so on, AN BN. A1 by B1, A2 by B2 and so on, AN by BN or not in AP. If you take the same examples, it will become very clear to you. First I am multiplying. 2 3s are 6. Okay. 4 5s are 20. Okay. 6 7s are 42 and so on. Is not an arithmetic progression. Since verify the common difference. If you do T2 minus T1, 20 minus 6 is not 14, but 42 minus 20 is 22, which is not an AP. So keep in your mind, if you multiply the corresponding terms of two APs, the results, if you multiply or divide, the result will not be an AP. Now we will go to the next one. To property number 5, it is very important in solving the problems. Okay, students? So what it says, if three numbers in AP whose sum is given, in some particular problems they will give you sum and product of the terms. Then they will ask what are the terms, then what is an AP. And at that time it will become very easy if sum is given. See, if A and D are the first and common differences of an AP, then you can take three terms as A minus D, A plus D, if sum is given. Why? Because an addition of these terms, okay, A minus D plus A plus A plus D. You can cancel this minus D and plus D. You will get a result in A. That means you can get A value directly without any problem. This is our convenience, but it is not a rule. If you assume like that, your problem will become very easy, and after finding A value, you can substitute A value in the product of the terms given. Then you will get the common difference. After finding A and D, you can easily find the 3 terms or 5 terms, whatever the number of terms may be. Here, if you want to assume 5 terms whose sum is given, then it's very simple. First assume the middle term as A, then its next terms A plus D, A plus 2D. and its before terms a minus d, a minus 2d. If you want to 7 terms, so you have to add a plus 3d on the right side and a minus 3d on left side. So if you want to generalize, and assuming the terms, if you have given odd number of terms of an AP, then first take a as your middle, then expand the number of terms on the right as well the number of terms in the left, which are equal to each other with common difference d. If you verify this, you will get the common difference d. Okay. Similarly, if you want to assume the number of terms when they have given in even number, then with first term a and common difference d, you can assume two terms as a minus d, a plus d. In this case also, if you add this, you can cancel plus d and minus d, you will get value of a first, then it is very easy if you know the one variable to find the next variable. Similarly, if you want to assume 4 terms, start with a plus d and a minus d. Then the common difference here is 2d, but here is only d. If you observe, a plus d minus a minus d, that will become 2d. A plus d minus a plus d. This minus a plus a will get cancelled. You will have 2d as your common difference when you want to assume even number of terms, when the sum of the terms is given and you are able to find the terms of the arithmetic progression. Okay, we will have another one which is also important, the last one but not least. If a1, a2, a3 and so on a are the terms of an AP, then if you want to find any particular term, let it be AR. AR can be obtained AR minus K. This is the term number. Okay. AR minus K plus AR plus K, where K is a constant. Means AR minus K means you are going backward of this term, and AR K plus 1 means you are going forward of this term. By adding this and dividing with the 2, you will get any particular term where for all this case, whatever the K may be, and this, see, K may be, that is since you are finding the term number, it should be natural number, and this K value should be between and including 0 and n minus r. Then you can get any particular term in the given arithmetic progression. Thank you for watching me. I hope this video will be helpful to you. If you feel that this is helpful to you, don't forget to subscribe to my channel and like it, share it to your friends who are in need of this type of videos. Every day I will post a video at 6 p.m. So thank you for watching again. We will meet in the next video.